In the electrical industry, two main methods exist for terminating wires: stab connections and screw terminals. Each method presents distinct advantages and disadvantages. Stab connections offer the benefits of faster and easier installation, often requiring no tools. They are compact, making them suitable for tight spaces. However, stab connections are generally less secure than screw terminals. They are prone to arcing and overheating if not properly inserted, and can sometimes be difficult to remove wires from. Screw terminals, on the other hand, provide a more secure connection. They allow for tighter connections, accommodating different wire gauges. However, screw terminals are slower and more labor-intensive to install, requiring tools, and they can be bulkier than stab connections. Industry practices vary in the preference for stab connections versus screw terminals, depending on the industry and application. In residential work, stab connections are commonly used because of their speed and ease of installation. In commercial and industrial settings, screw terminals are typically favored for their higher reliability and enhanced safety. In industrial control panels, screw terminals are almost exclusively used due to their versatility and secure connections. Many electricians report experiences with faulty stab connections, which can be problematic in time-sensitive or high-stakes applications. As a result, many electricians prefer screw terminals for the added reliability they provide. A cynical view might call stab connections a form of job security, but this is irresponsible. It implies that electricians intentionally create problems to ensure continued employment, which is unethical and goes against the principles of safety and professionalism. Ultimately, the choice between stab connections and screw terminals should be based on the specific application and adherence to industry standards. Screw terminals are generally preferred when higher reliability is needed, while stab connections offer speed and convenience in appropriate contexts. It is essential to use proper installation techniques to ensure secure connections, regardless of the chosen method. When dealing with electrical wiring, several factors influence the selection of wire size and the appropriate breaker or fuse size to protect the circuit. These include the ampacity of the wire, the load requirements, and relevant electrical codes. Ampacity refers to the current carrying capacity of a conductor, which is the maximum amount of electrical current a wire can continuously carry without exceeding its temperature rating. The National Electrical Code, or NEC, provides tables such as Table 310.15, B16, that list the ampacities for various wire sizes and insulation types. For example, copper wire with a type THHN insulation might have an ampacity of 20 amps for 14 gauge, 25 amps for 12 gauge, and 30 amps for 10 gauge. Aluminum wire has different ampacity ratings than copper due to its higher resistance. A 12 gauge aluminum wire might have a lower ampacity rating than a 12 gauge copper wire. It's crucial to consult the NEC tables for accurate ampacity values. When selecting wire size, it's important to consider the load requirements of the circuit. This involves calculating the total current that the connected devices or appliances will draw. For example, if a circuit will power several lights and a small appliance, you need to add up the current draw of each device to determine the total load. The wire must be able to handle this load without overheating. Electrical codes, such as the NEC, specify requirements for overcurrent protection, which is typically provided by circuit breakers or fuses. These devices are designed to trip or blow when the current exceeds a safe level, protecting the wiring and connected equipment from damage. The size of the breaker or fuse must be matched to the ampacity of the wire. For example, a 14 gauge wire with an ampacity of 20 amps should be protected by a 20 amp breaker. It's important to note that the NEC has specific rules regarding the use of certain wire sizes for specific applications. For example, a 15 amp circuit typically requires a minimum of 14 gauge wire, while a 20 amp circuit typically requires a minimum of 12 gauge wire. Following these rules ensures safety and compliance with electrical codes. Voltage drop is another important consideration when selecting wire size, especially for long circuit runs. Voltage drop refers to the decrease in voltage along the length of a wire due to its resistance. Excessive voltage drop can cause lights to dim, motors to run inefficiently, and electronic equipment to malfunction. To minimize voltage drop, you may need to increase the wire size. The NEC provides guidelines for calculating voltage drop and recommends limiting it to a certain percentage of the source voltage. For example, a maximum voltage drop of 3% is often recommended for branch circuits. Environmental factors can also affect wire ampacity. For example, wires installed in conduit or in areas with high ambient temperatures may have a low ampacity rating. The NEC provides adjustment factors for these conditions. It is important to apply these factors when selecting wire size. When working with electrical wiring, it is essential to follow all applicable electrical codes and safety regulations. This includes obtaining the necessary permits, using approved materials, and following proper wiring methods. If you are not familiar with electrical work, it is best to consult with a qualified electrician. They can help you select the appropriate wire size, breaker size, and wiring methods for your specific application. Improper wiring can create a fire hazard or electrical shock hazard. Always prioritize safety when working with electricity. In summary, selecting the correct wire size and breaker size involves considering the ampacity of the wire, the load requirements, overcurrent protection, voltage drop, environmental factors, and electrical codes. Consulting the NEC and working with a qualified electrician are essential steps in ensuring a safe and compliant electrical installation. Understanding grounding and bonding is crucial for electrical safety. Grounding provides a path for fault current to return to the source, allowing the overcurrent protection device, such as a circuit breaker or fuse, to trip and to energize the circuit. Bonding connects non-current carrying metal parts of the electrical system together, creating a low impedance path for fault current. The main grounding electrode is typically a ground rod, a metal water pipe, or a concrete encased electrode, also known as a U for ground. The grounding electrode conductor connects the grounding electrode to the neutral bus in the main service panel. The size of the grounding electrode conductor is determined by the size of the service entrance conductors, as specified in the NEC. Bonding conductors connect metal enclosures, such as electrical boxes, conduit, and equipment to the grounding system. This ensures that all metal parts are at the same potential, minimizing the risk of electric shock. The size of the bonding conductors is determined by the size of the circuit conductors, as specified in the NEC. Ground fault circuit interrupters, or GFCIs, are important safety devices that protect against electric shock. GFCIs monitor the current flowing in the hot and neutral conductors of a circuit. If there is a difference in current indicating a ground fault, the GFCI will trip and interrupt the circuit. GFCIs are typically required in wet locations such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, or AFSIs, are another type of safety device that protects against electrical fires. AFSIs detect arc faults, which are dangerous electrical discharges that can occur in damaged or deteriorated wiring. When an arc fault is detected, the AFSI will trip and interrupt the circuit. AFSIs are typically required in bedrooms and other areas where fire hazards are more likely. Surge protective devices, or SPDs, protect electronic equipment from voltage surges, such as those caused by lightning strikes or power grid switching. SPD divert excess voltage to ground, preventing damage to sensitive electronic components. SPD are available in various types, including whole-house surge protectors and plug-in surge protectors. Electrical panels, also known as load centers, distribute electrical power to different circuits in a building. Electrical panels contain circuit breakers or fuses that protect each circuit from overcurrent. The size of the electrical panel is determined by the total load requirements of the building. Electrical boxes are enclosures that protect wiring connections and provide a safe mounting location for devices such as switches and receptacles. Electrical boxes are available in various sizes and materials, including metal and plastic. Conduit is a protective tubing that encloses electrical wiring. Conduit is typically made of metal or plastic and is available in various sizes and types. Conduit protects wiring from physical damage and provides a path for pulling wires through walls and ceilings. Wiring methods refer to the techniques and materials used to install electrical wiring. Common wiring methods include non-metallic sheet cable, also known as Romex, and metallic conduit. The choice of wiring method depends on the application and local electrical codes. Electrical codes, such as the NEC, provide detailed requirements for electrical installations. These codes cover topics such as wiring methods, grounding, bonding, overcurrent protection, and safety devices. It is essential to follow all applicable electrical codes when performing electrical work. Safety is paramount when working with electricity. Always to energize circuits before working on them. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not familiar with electrical work, it is best to consult with a qualified electrician. They can help you with electrical installations and repairs. Remember that improper electrical work can create a fire hazard or electrical shock hazard. Always prioritize safety. In summary, understanding grounding, bonding, safety devices, electrical panels, electrical boxes, conduit, wiring methods, electrical codes, and safety practices is essential for working with electricity safely and effectively. Always follow applicable codes and consult with a qualified electrician if you have any questions or concerns. Generators provide backup power during power outages. There are two main types of generators: portable generators and standby generators. Portable generators are smaller and can be moved from one location to another. Standby generators are larger and are permanently installed. When selecting a generator, it is important to consider the power requirements of the devices and appliances you want to run. Generators are rated in watts, so you need to calculate the total wattage of the loads you will be connecting to the generator. It is also important to consider the starting wattage of motors, which can be several times higher than the running wattage. Transfer switches are used to safely connect a generator to a building's electrical system. A transfer switch prevents the generator from backfeeding into the utility grid, which can be dangerous for utility workers. There are two main types of transfer switches: manual transfer switches and automatic transfer switches. Manual transfer switches require you to manually switch between the utility power and the generator power. Automatic transfer switches automatically switch to the generator power when the utility power fails. When using a generator, it is important to follow all safety precautions. Never operate a generator indoors or in a confined space, as this can lead to carbon monoxide poisoning. Always use a carbon monoxide detector when operating a generator. Fuel storage is another important consideration when using a generator. Gasoline and diesel fuel are flammable and should be stored in approved containers. Store fuel in a well-ventilated area away from heat sources. Regular maintenance is essential for keeping a generator running properly. This includes changing the oil, cleaning the air filter, and inspecting the spark plugs. Refer to the manufacturer's instructions for specific maintenance recommendations. Solar panels convert sunlight into electricity. Solar panels are typically installed on rooftops or in open areas where they can receive direct sunlight. Solar panels are made of photovoltaic cells, which generate electricity when exposed to sunlight. Inverters convert the direct current, or DC, electricity produced by solar panels into alternating current, or AC, electricity, which can be used to power homes and businesses. There are two main types of inverters: string inverters and microinverters. String inverters are typically used in residential solar systems. Microinverters are installed on each individual solar panel. Net metering allows solar panel owners to sell excess electricity back to the utility grid. When the solar panels produce more electricity than the building consumes, the excess electricity is sent back to the grid, and the utility company credits the owner's account. Energy storage systems, such as batteries, can store excess electricity produced by solar panels. This allows solar panel owners to use the stored electricity during times when the sun is not shining. The cost of solar panels has decreased significantly in recent years, making solar energy more affordable. Government incentives, such as tax credits and rebates, can also help reduce the cost of solar panels. Solar energy is a clean and renewable source of energy that can help reduce reliance on fossil fuels. Wind turbines convert wind energy into electricity. Wind turbines are typically installed in areas with high wind speeds. Wind turbines are made of blades that rotate when the wind blows, turning a generator that produces electricity. The size of a wind turbine is determined by the amount of electricity it can produce. Small wind turbines are typically used for residential applications, while large wind turbines are used for commercial and industrial applications. Wind energy is a clean and renewable source of energy that can help reduce reliance on fossil fuels. Energy efficiency is the practice of reducing energy consumption. There are many ways to improve energy efficiency, such as using energy-efficient appliances, insulating buildings, and using energy-efficient lighting. Energy-efficient appliances use less energy to perform the same tasks as standard appliances. Energy-efficient appliances are typically labeled with the Energy Star logo. Insulation helps to keep buildings warm in the winter and cool in the summer, reducing the need for heating and cooling. Energy-efficient lighting, such as LED lights, uses less energy and lasts longer than traditional incandescent lights. Energy efficiency can save money on energy bills and reduce environmental impact. Smart home technology allows you to control and automate various aspects of your home, such as lighting, temperature, and security. Smart home devices can be controlled remotely using a smartphone or tablet. Smart thermostats can automatically adjust the temperature based on your schedule and preferences. Smart lighting can be controlled remotely and can be programmed to turn on and off at specific times. Smart security systems can monitor your home and alert you to any potential threats. Smart home technology can improve convenience, comfort, and security. When working with electrical systems, safety should always be the top priority. Before starting any electrical work, it is important to energize the circuit by turning off the circuit breaker or removing the fuse. Use a voltage tester to verify that the circuit is de-energized. Wear appropriate personal protective equipment, such as safety glasses and gloves. Use insulated tools to prevent electric shock. If you are not familiar with electrical work, it is best to consult with a qualified electrician. Electrical codes and regulations are in place to ensure the safety of electrical installations. These codes and regulations vary depending on the location. It is important to be familiar with the electrical codes and regulations in your area. Permits may be required for certain types of electrical work. Check with your local building department to determine if a permit is required. Inspections are typically required after electrical work is completed. An electrical inspector will verify that the work was done in accordance with the electrical codes and regulations. Proper grounding is essential for electrical safety. Grounding provides a path for fault current to return to the source, which helps to prevent electric shock. All metal electrical boxes and equipment should be grounded. Ground fault circuit interrupters, or GFCIs, are designed to protect against electric shock. GFCIs are required in wet locations, such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, or FCIs, are designed to protect against electrical fires. FCIs are required in bedrooms and other areas where fire hazards are more likely. Surge protection devices, or SPDs, are designed to protect electronic equipment from voltage surges. SPD should be installed at the service entrance and at sensitive electronic equipment. Regular maintenance is essential for keeping electrical systems running safely and efficiently. This includes inspecting wiring, tightening connections, and replacing worn or damaged components. Carbon monoxide detectors should be installed in all homes with fuel-burning appliances, such as furnaces, water heaters, and generators. Carbon monoxide is a colorless, odorless gas that can be deadly. If you suspect a carbon monoxide leak, evacuate the building immediately and call the fire department. In conclusion, electricity is a powerful force that can be dangerous if not handled properly. By following safety precautions, adhering to electrical codes and regulations, and performing regular maintenance, you can ensure the safety of your electrical systems. Always prioritize safety when working with electricity.